Hello friends, welcome back. Hearty welcome to you. Let us look at this problem related to 10th or 11th grade coordinate geometry straight lines. We have been given that a square and isosceles triangle of equal height are side by side as shown in the figure with both bases on the x-axis. The lower right vertex of the square and the lower left vertex of the triangle both are at 10, 0. The side of the square and the base of the triangle on the x-axis equals to 10 units. A segment is drawn from the top left vertex of the square to the farthest vertex of the triangle as shown. What is the area of the shaded region? Now we can solve this problem using geometry concepts, similarity of triangles, or we can solve it using coordinate geometry. We are solving lot of problems with the geometry, so let us for a change try to solve this with coordinate geometry. So coordinate geometry means first we have to get all the coordinates. So let us start with origin. Our origin is 0, 0. Now we know that the side of the square and the base of the triangle both are of same length. That means this coordinate will be 20, 0. This point coordinates will be 20, 0. Also we know that side of the square is 10 units. So this point coordinates will be 0, 10. And what else we need? We need the area of the shaded region. That means we need to have the coordinates of the 3 points. That means this particular point coordinates are missing. So we need to find out that particular point coordinates. To do that, we have to get the equation of both the lines and we solve them to find out the point of intersection. So that is where we will be using the straight lines concept. Okay, now what will be the coordinates of this particular point? Can we think about that? Because 10, 0, 20, 0 exactly in the middle will be 15 and the height we know is 10. So that point coordinates will be 15, 10. Now instead of saying this and that, let's just try to put some alphabets there. The line is AB and let us say this is CD. Now we want to find out the area of the shaded region. We have to find out the coordinates of the point X. Point X is the point of intersections of lines AB and CD. Now let's try to find out what is the equation of line AB and what is the equation of line CD and try to solve them to find out the coordinates of X. Once we are able to get the coordinates of X, easily we can calculate the area of the shaded region. So let us first write down what is the equation for AB. The equation for AB, we have one point 0, 10, another point 20, 0. So I know x-intercept is 20 and y-intercept is 10. So I can use double intercept form and I can write down the equation as x by 20 plus y by 10 equals to 1. That is our equation for line AB. Now let's try to find out what is the equation for CD. We have again 2 points there. The points are 10, 0 and 15, 10. We can use here 2-point form. We will say y minus y1, that is y minus 0 equals to slope into x minus x1, that is x minus 10. What is our slope? Slope is y2 minus y1 by x2 minus x1, that is 10 minus 0 divided by 15 minus 10. Can we simplify that? It will be y equals to 2 into x minus 10. Now we have two equations here. First equation, second equation. We try to solve this to find out the coordinates of point X. Once we get the coordinates of x, then we can easily calculate the area of shaded region. So let us say the coordinates of x are x1 comma y1. In that scenario, x1 comma y1 should satisfy both the lines AB and CD. So we will have two equations, x1 by 20 plus y1 by 10 equals to 1. y1 equals to 2 into x1 minus 10. Now in place of y1, let us substitute 2 into x1 minus 10 and try to solve for x1 and y1 values. So let us do it. We will write down x1 divided by 20 plus y1, which is equals to 2 into x1 minus 10 divided by 10 equals to 1. In place of y1, we have substituted 2 into x1 minus 10. Now we can take LCM here. We'll multiply with 2 and 2 here so that the denominator will become 20. Can I write down then x1 plus 4 into x1 minus 10 equals to 20? Can we simplify that and say that 5x1 equals to 60 or x1 equals to 12? So we got x1 equals to 12, then y1 we know already that y1 equals to 2 into x1 minus 10. That is equals to 2 into 12 minus 10, which is equals to 4. So we know that x1 comma y1 is 12 comma 4. Now let us substitute in place of point x, x1 y1 as 12 comma 4. Then we will calculate the area of the shaded region. Now once we got the coordinates of x as 12 comma 4, it's very easy to calculate the area of the shaded region, because we can apply the formula half into base into height without any issue, because we are dealing with a horizontal line as the base. Now what is our base? Our base is 20 minus 10, which is equals to 10. And what is our height? Height is given by the y coordinates of the point x, which is equals to 4. So the area of the triangle is equals to 20 square units. Now you can solve the same problem using geometry concepts, similarity of triangles. But in this session, we try to solve it using coordinate geometry. So let's have a recap of this problem. This problem is for 10th or 11th grade coordinate geometry, straight lines. A square and isosceles triangle of equal height are side by side as shown with both bases on the x-axis. The lower right vertex of the square and lower left vertex of the triangle are at 10, 0. The side of the square and base of the triangle on the x-axis each equals to 10 units. A segment is drawn from the top left vertex of the square to the farthest vertex of the triangle as shown. What is the area of the shaded region? So we have been given that the side of the square is 10 units and the coordinates of the lower right vertex of the square and the lower left vertex of the triangle coinciding at point 10, 0. Now we started placing the points and their coordinates. So we know origin is 0, 0, 10, 0. Then we got that coordinates of B are 20, 0. We can easily find out coordinates of C, because C is exactly will be from x, exactly will be the midpoint of B and D with respect to x coordinate. So it will be 15 and the height will be 10. So 15, 10, because we have been given the square and isosceles triangle are of equal height or side by side. So we know coordinates of C, we know coordinates of D, we know coordinates of A, we know coordinates of B. We used the straight line forms to find out the equation of AB and equation of CD. The point of intersection of AB and CD is point X. We are able to find out what are the coordinates of X. Once we know what are the coordinates of X, then the area of the shaded region is, we can apply the generic formula half into base into height. We know the base is horizontal line here. So half into base into height will give us half into 10 into the height of the altitude with respect to the base, that is 4 units. So the area is half into 10 into 4, 20 square unit.